Hi everyone. I'm Smriti Purwar. I'm working as a project scientist too in National Center for Medium Range Weather Forecasting, Ministry of Earth Science, India. Currently, I'm presenting about my recent work, which is going on right now. So, the topic is evaluation of GNSS-ZTD and OSSE framework for dense network of GNSS over Indian region. So, firstly, I present about the introduction and motivation for this work. As we already know that the data assimilation is a very crucial process for improving the initial condition in weather model. So firstly, the accurate moisture representation is also very crucial for the precipitation forecast especially, and particularly over the Indian region where we can see the strong monsoon variability, high rainfall impact, and there is also very sparse network of conventional observation. So today I am discussing about the GNSS-ZTD, which give the information about the total column water vapor. And also in earlier studies, we have seen that the ground GNSS station give uh, give uh, means the very significant impact per observation. It's in the fourth position. If we can see that, and also we have planned OSSE for this because currently in India we have very sparse network of GNSS ZTD, and we want to see that if we proposed a high density of network of GNSS in India, then what will be the impact of these stations over Indian region, especially for the rainfall forecast. So currently, we get around 28 ground GNSS station through IMD, which is the India Meteorological Department. The location of these GNSS station we can see in the GNS means in the left side, and we have proposed around 348 ground GNSS stations. These locations are the synop location, and we are proposing some GNSS GPS observation in these locations. So the objective of this work, firstly, we have to get one nature run basically the real atmospheric condition which we need to give in the model to simulate the means true observations from that real atmospheric condition. So firstly we need one nature run, and then we simulate some observation from these nature run, and then we will do one experiment with a control where we don't assimilate any GNSS observation, and in the experimental we will assimilate these 348 station which we have proposed, and we'll see the advantage of OSSE is means we know the truth, and we get to know the impact of these before investing any cost for the GNSS station. We will get to know what is the impact of these stations if uh, we proposing these stations, what will be the impact of these stations in the weather model. So firstly we have to know there are so many products available in weather model which we can use as a nature run. So firstly we have to know which will be the appropriate for our Indian region. So firstly, we have done one study for the simulating of ZTD. So ZTD is nothing but the means the vertical column vapor information, which so firstly will calculate the atmospheric refractivity for this calculation of ZTD. In this we need to calculate the atmospheric refractivity for each vertical level, and then we integrate or sum up all these vertical refractivity and get the ZTD for this location. So for the ZTD calculation, we mainly need pressure, water vapor pressure, and the temperature. So result of this thing, firstly I'll discuss what data I have used for this study. So firstly I have used ERA 5 data, which is a global reanalysis data, 31 kilometer resolution and 137 vertical resolution. For other data, I have used NCMRWF Unified Model, NCOM, and NCMRF GFS model, which is also global analysis data. NCOM is 12 kilometer resolution and the vertical level is 70 kilometer. Until 70 kilometer we'll get. And and for the NGFS, we have taken horizontal resolution 25 kilometer and the model level still 64 kilometer will get. Sorry, these are not kilometer, these are levels. So 70 levels and the 64 levels will get in the model levels. And so if we see the result, these in the x-axis we can see the stations, IMD stations, and we have compared these reanalysis simulated ZTD with the observed rainfall for IMD stations, and we have got this result. If we see the average of this result, we can see for ERA 5 we have got around 0.094 meter, which is high, particular if we compare with the NCOM and NGFS. NGFS is showing significant good result for this study, which is 0.061 meter RMSE in ZTD we have got. We want to know that this result is specifically for Indian region or it will so for all the regions. So we also extended this study for the Japan region. These are the Japan GNSS stations locations which we have shown in the left side, and this also I have calculated RMSE by taking ERA 5, NCOM and NGFS and compared with the Japan GNSS stations data, observed GNSS station data, and these are 46 stations which we have taken in this study over Japan, and we also got this result for Japan region also, where the ERA 5 showing very high RMSE, around 0.128 meter, and for NGFS is very low, 0.025 meter. So the main region which I have think about for RMSE, it's mainly maybe the ERA 5 ERA 5 data. The horizontal resolution is very high if we compare with the NCOM and NGFS. Also in ERA 5 preparation we don't use ground GNSS observation in the assimilation process, where in NCOM and NGFS preparation we used assimilation of ground GPS station. So this might be the reason which we have not getting good result for ERA 5. Also now, because we have got that the NGFS is showing particular good result for GNSS ZTD. So for the nature run, I have used NGFS analysis data. I have simulated for ZTD over 348 GNSS stations which we have proposed, and also we have done the control and experimental assimilation system for 1 month, which I particularly took August 2025. And now we will see the impact of ground GNSS ZTD observation. So because we know that in the model, if the real observation, the quality is good, but also even if the quality is good, the observation is not able to assimilate in the model, because there is for every observation there is a limit of O minus B. This is observation and background, which also which may be the particular region, which because of that the real observation of good quality also can be rejected by the model. So here also we can see particular for GNSS ZTD we mostly take 0.03 O minus B thing. So here around 250 station I have taken for this particular thing, to see how much it is varying if we just play with the O minus B thing. So this one is observation bar of thing and the model of which we have taken background, and we can see if it is between 0.0 means less than 0.03, so there is very less observation assimilated by the model, which mainly in the south of Indian region. If we increase this O minus B from 0.03 to 0.1, there will be 69 observation, which is also convergent to the south region. And then if we increase by 0.3, which is 10 times of which we took operationally here, around 235 station is going inside. So because we are getting this problem after getting 348 stations in GNSS, only 21 stations was going inside in the model, and we were not able to see the impact of these stations. So we have done one bias correction thing. So for this, we have taken 28 days, 28 days models and observation ZTD, and calculated average of the error between model and observation for each station. And we have done the first a observed ZTD, and then we have calculated the bias corrected ZTD for the particular day. And the model ZTD, which model means the background. So this is the model ZTD, and we can see if we take a 0.03 O minus B, around it 130, 1355 observations are going inside, uh, in total 2088. Sorry. So this is a preliminary result, so I'm not showing, means I haven't prepared much, but I have this result particular. So this is the rainfall of 12th August in India region. The first one is showing the IMD observed rainfall, and this the second one is IMERGE rainfall. So we have taken this particular event for our study, and this we have seen this how much these 348 proposed GNSS ZTD impacting on the result of for this space rainfall event. The first row, if we see in the right side, A, B, and C, these are control minus observations, and we can see that there is in the north side there is a overestimation of rainfall. A is the forecast one, means prior one day, and this is B is 3 forecast day 3, and the C1 forecast day 5. So in this we can see the control is showing, so means in somewhere it is showing the overestimation of rainfall, particularly in the north side and the central. And if we go in the day 3 and day 5, this central rainfall is reduced. Now, if we see the experiment with OSSE, so in DEN, this is day 1, day 3, day 5, OSSE experiment, which is OSSE experiments minus control, means with if we compare with the control, how much it is deviating with the forecast. So here we can see that for the forecast 1, I have calculated improvement parameter, which is IP. Improvement parameter is nothing but we have calculated with the RMSE. For the forecast one day, we have got improvement around 0.3%. If we see the day 3 forecast, we have got around 1.5% improvement, and in the day 5 we have got 2.7% improvement. In day 3, in day 1 we didn't get much improvement because of we have assimilated so many data. There is also it is generating some error, which can be the reason it is not improving that much the rainfall over Indian region. So So this is the conclusion. Means Era 5 is not so good, giving not so good performance for GNSS-ZTD simulation, and GFS is performing very well. So that's why we have used as a nature run in our study. And also in the preliminary result also we have seen that the high density of GNSS observation is improving the rainfall forecast for Indian region. This paper is already submitted in our and the one paper is already submitted in general, and one is going on in the drafting. So this is from my side. Thank you.
Thank you for
Is
the
there
talk.
any question?
I
I
have a
can take.
few.
Yeah.
So first off, this NGFS that you used as the nature run, what is that? I'm not familiar with it.
NGFS is the NCMRF GFS model. In where I am working, National Center for
Yeah.
Medium Range Weather Forecasting, we have bought two models. One is from UK and one is from USA. So NCOM is the UK Met Office one, which is NCMRS Unified Model NCOM, and one NGFS is an NCMRS GFS model. So this is that I have used in my study. And also the ERA 5 is reanalysis, and NGFS and NCOM is analysis products. So that's
So
why maybe, yeah,
so you use that as your nature run,
yeah,
but it was so, if I got it right, so the difference between the nature run and the background were large enough that without bias correction, almost all of the observations were rejected.
yeah.
Okay.
Actually in ZTD, it's in some paper in previous study also I have read that it is very crucial in especially for GNSS ZTD to do the bias correction thing. In many previous study also they have taken, and in the model also it's inbuilt. So I have used that thing.
Okay, thanks. Question from Sarah Dance. Which scores do you plan to use to assess the OSSE results more statistically?
Sorry, I didn't get that.
Yeah. So which scores do you use to assess your OSSE improvements?
Currently I'm thinking about the equitable threat score, but because it is good, it gives a good result for especially for the rainfall forecast. So I'm thinking to use ETS, but I can use BS and all. I can see how it is varying with the OSS thing, but mainly I will
Excellent.
focus on the ETS thing.
Okay, thanks. And just a pause to stop the recording.